In activity 4.5, we're going to investigate distance traveled given the velocity function v of t equals 2/9 times the quantity t minus 3 squared plus 2. So here we have the plot, and we're going to look on this on the interval from 2 to 5. So 2 to 5, and we know that the distance traveled is the exact area under this curve between 2 and 5. Now what we're going to do is we're going to approximate this area with 3 different methods: the left-hand rule, the right-hand rule, and the midpoint rule. And we're going to use 4 rectangles. So first, let's talk about the left-hand rule, L sub 4. So if we're going to break all these into 4 subintervals, the length of our interval is 5 minus 2, and we're breaking it into 4 subintervals, is 3/4, and that will be our delta t in this problem. So we want to break these up into 3/4. So that means right here, we're starting at 2. Right here is 2.75. We're going to go another 0.75, and this is 3.5. Going another 0.75. Here we got 4.25, and then to 5. So these are going to be where we build our rectangles. Now we're going to use the left-hand rule, so that means the left end is going to make the tops of our rectangle. So we're going to come over and down. Left end, over, and down. Left end, over, and we don't need to go down on that one. So that would be our left-hand rule there in the green. So what we're going to do is we're going to have our delta t, which is 3/4, times our function evaluated at each left end endpoint. So at v of 2 plus v of 2.75 plus v of 3.5 plus v of 4.25. Calculating that, we're going to get the left-hand rule gives us a distance traveled of 6.47917. And in this particular case, our distance is in feet, so that's going to be our estimate of the distance traveled in feet from the left-hand rule. Real similarly, we can do a right-hand rule. We're already set up for it. So I'm going to come, and my rectangles now are going to be made by the right-hand point. So we can see we're going to get a little bit different estimate of our area. So R sub 4 consists of a lot of the things that the left-hand rule did, except it doesn't use the leftmost point, but it will use the rightmost point. So all these points are going to stay the same. The v of 2.75 plus v of 3.5 plus v of 4.25 plus v of 5 is now added on. And if you calculate this, you get 6.97917 for the right-hand rule. All right. So based on our rectangles, it looks like our distance traveled is somewhere in between there. Now, lastly, we're going to do this with the midpoint rule. Okay, the midpoint rule we do need to recalculate because we need the midpoint of each of these intervals. So I need this point here, which is 2.375. I need this point here, which is 3.125, because I'm cutting all my intervals in half. From 3, I need to cut this interval in half, so that happens at about 3.875. And finally, I need to cut this interval in half, which happens at about 4.625. Now, that's what I'm going to use for my rectangle heights. So hopefully this drawing isn't getting too convoluted, and you can see the rectangle there in the blue. We had seen in the preview activity the midpoint rule gives a little bit better estimate. Actually, it might have been in the last activity. Gives a little bit better estimate than the left hand and the right hand. Now the midpoint rule is going to use those values instead. It's still a 3/4 for our delta t, but v is going to be calculated at our midpoint of each interval. So it's good that we found them in the last step, and we're going to sum those up to get 6.63542. Now, this is more accurate than the left hand and the right hand. Now, what if we averaged the left hand rule and the right hand rule? So L sub 4 plus R sub 4 over 2. If you do that, you get 6.72917. So that's different than the midpoint rule. We actually have a name for this as well. This is called the trapezoid rule with 4 intervals. So the trapezoid rule gives us 6.2917. Interestingly enough, in this problem, the actual area under the curve is, and we're going to learn how to calculate this in a little bit and soon, is 6 2/3, or 6.67 repeating. The midpoint rule is slightly closer than that than the trapezoid rule, and that's always going to be the case. The midpoint rule is a little slightly more accurate than the trapezoid rule, which is the average of the left hand rule and the right hand rule. Finally, one other thing to bring up as far as what we can tell about when things will be an overestimate or an underestimate, particularly the left hand rule and the right hand rule. If you look at the way our rectangles sit, if we make a corner here and we use a right hand rule, notice if the function is decreasing, our rectangle will sit underneath. But if our function is increasing and we're using a right hand rule, our rectangle will sit above. So the right hand rule is an underestimate if our function is decreasing, and an overestimate if our function is increasing. The left hand rule is exactly the opposite. The left hand rule will be an overestimate if our function is decreasing, and the left hand rule will be an underestimate if our function is increasing.